Since colonial times, the vast expanses of ocean waters have played a key role in our country's history. The oceans were its windows on the world and broad avenues for trade and commerce. At the same time, they were bastions separating the young republic from the tensions and conflicts of other continents. To keep its shores safe from attack, the nation had only to maintain stout ships and weapons, manned by men of skill and courage that could operate on the surface of the water. But modern technology has changed all that. The oceans no longer protect. Instead, they provide hidden pathways to our shores and concealed submarines that can launch missiles from far at sea. The great strategic military importance of the oceans makes it imperative that the nation have a strong, versatile navy, able to operate with full effectiveness in all the world's oceans. As never before, the Navy requires full knowledge of the ocean environment and the ability to use it to best advantage. The Navy must be able to predict what that environment will be. But to achieve reliable prediction systems, enormous amounts of data must be collected, analyzed, and interpreted. To gather essential information, the Navy sends its submersibles to probe into the darkest depths of the oceans. And its oceanographic ships continually go to sea. Many of the ships and their scientists gain new knowledge on research cruises. They use Nansen bottles and other samplers to bring up ocean water from various depths. They carefully analyze the seawater in the laboratory for salinity and other factors. They send down dredges to drag the bottom and retrieve specimens for study. Their cameras descend into the ocean and record what their eyes cannot see. The scientists also use plankton nets to bring up tiny shrimp-like organisms that are the life of the sea. They use electronic sensors to record vital data. And they send down heavy coring devices that plunge deep into the ocean bottom, bringing back cores that contain a geological history of the sediment layers. other ships designed to support the fleet in forward areas, mainly to gather hydrographic data, measuring physical features of ocean and adjoining coasts, to produce accurate charts of amphibious operating areas, coastal waters, and harbor and channel approaches. A hydrographic survey operation first begins on land, often in inaccessible locations, from a known point where a tower is erected to serve as a navigation reference. Aboard a naval survey ship, each day's action is planned in every detail. The ship and its sound boats then conduct an offshore bathymetric survey, measuring water depths and defining the topography of the ocean bottom. The sound boats obtain the data in shallow water areas. Enlisted personnel are deeply involved in every phase of the survey. While a bosun's mate acts as coxswain, a quartermaster keeps running track of the boat's precise position, using radio transmissions from the navigational aids previously set up ashore. The sound boat takes soundings electronically, measuring the time it takes for a sound signal to travel to the bottom and to be reflected back. A computer records the soundings on magnetic tape. For backup, another crew member monitors the data input. An electronic technician is also aboard to maintain the equipment. The ship itself works in deeper coastal waters to conduct another bathymetric survey. As the ship follows an assigned track, it electronically takes depth soundings. A computer combines depth and position data and records and stores the information. Additional data required for the drawing of boat charts is fed into the computer. And the plotter draws the boat charts from the computer data derived from recorded depth and position information. Survey control personnel monitor and record essential data. The system also prints a running profile of the ocean bottom on a fathometer. Personnel aboard the survey ship prepare their own charts from the raw data gathered during the survey. Other naval oceanographic ships run depth surveys in still deeper ocean areas. Out of range of shore-based navigational fixed stations, these ships get their position information from satellites. Hydrographic, magnetic, and other data gathered by the Navy's ships and aircraft are used to produce charts and other printed materials. Bathymetric data provide the basis for bathymetric contour charts. Atlases of large ocean areas provide bottom topography information primarily for naval operations, but also meet other needs, among them scientific research, environmental planning, and search and salvage. The Navy also studies waves, and for good reason. Waves are generated by wind blowing over the water, the energy in the one medium transferred to the other, and play a considerable role in the ocean environment. They slow up ships, damage cargo, discomfort passengers and crew. High waves distort radar return and increase the noise level that interferes with sonar operations. Fleet Weather Centrals forecast wave conditions in the different ocean areas and recommend the best routes for naval shipping to take. Not only winds cause movement of the ocean surface. Here, the edge of the Gulf Stream can be seen clearly as it flows through the Atlantic. Many currents and countercurrents, so-called rivers of the sea, traverse the oceans and affect naval operating conditions. It is necessary to know where they are, which way they flow, and how fast. Many of the currents flow at depth and along the ocean bottom, and are of special significance to the submariner and submarine hunter. In certain parts of the world, knowledge of the movement of sea ice is vital to navigation and effective naval tactics. For today, national interest in the Arctic is high. The pack ice that halts shipping in the winter and breaks up with the coming of warmer weather is a dynamic, ever-changing threat to the safe passage of ships and submarines. To predict its future behavior, the ice packs must be monitored. Personnel aboard naval aircraft record profiles of ice ridges and water openings in the ice. The plane flies low, following the edge of the pack, while an aerographer's mate observes the ice intently, noting what he sees, the kind of ice, the location, the ice concentration, its thickness, and the prevailing visibility. He also logs icebergs and ice islands. Periodically, he sends his notes back to his assistant, who is converting them to a chart format. At the end of the flight, the two men convert chart and data into message format. The ice data produced becomes part of the information supporting the Operation Ice Forecasting and Analysis programs of the Fleet Weather Facility at Submarine. This unique service provides a global ice analysis covering both the Arctic and Antarctic. Personnel whose training has put them among the world experts on sea ice produce a global forecast of ice movement and distribution for the next several days. While oceanography is vital to all aspects of naval operations, it plays a special role in undersea warfare. This is because the sound energy produced by a submarine has properties that can be analyzed and predicted. Sound, as it travels through the ocean, varies with temperature, salinity, pressure, and other factors. The sound is also affected by plants, animals, and suspended matter in the water. The behavior of sound traveling through the ocean must be understood so well that the performance of a particular system in a specific ocean area at any particular time can be predicted. The Navy is continually involved in research to collect and process detailed oceanographic data about the acoustic properties of all areas of the oceans. But gathering the information is not enough. Only when it is translated into operational use does its importance become significant to the fleet. Many enlisted ratings use the acoustic data for good purpose. The Ocean System Technician, or OT, is an expert in analyzing underwater sound. OTs monitor electronic signals from listening instruments placed in the sea. Everything that moves through the ocean deep creates its own sound patterns and makes its own electronic signals. OTs scan incoming data and select significant features for analysis. They sort out the sounds made by submarines or merchant ships or other surface vessels, by storms and waves, and by underwater marine life. Knowledge of how oceanographic factors affect underwater sound is essential to fleet operations, and is of vital importance in the actual effort to track down and destroy a hostile submarine. Anti-submarine warfare personnel not only have to know how sound behaves in water under various conditions, but must be familiar with the conditions to be expected in their operating area. Their mission begins prior to the flight, when the crew is briefed. At this time, the crew is provided with acoustic sensory range prediction system data, telling what the ocean acoustical environment in the mission area is expected to be. After the briefing and pre-flight check, the plane departs for the mission area. Aboard the P-3 aircraft, aviation anti-submarine warfare operators work closely with the tactical officer who directs the mission. Sonobuoys play a key role in this hunter-killer mission. When a sonobuoy is activated by seawater, an omnidirectional hydrophone is lowered from it to a pre-selected depth. A radio link relays the sounds picked up by the hydrophone to the aircraft as a hard copy papergram. From all information available, the tactical officer decides where to place sonobuoys and what hydrophone depth settings to give them. In arriving at this decision, he has considered complex factors ranging from water temperatures, densities, water layer depths, and bottom conditions to determine where a hostile craft is likely to exist. If the quarry can be picked up on two hydrophones simultaneously, its location can be pinpointed. When a submarine is located, the hunters close in on it. Hunter-killer squadrons operate from both carrier and land bases. Even as its aircraft range afar, the task force itself must maintain continuous vigilance against underwater attack. It must be able to detect the presence of the unseen craft before it is in a position to strike. From each destroyer in the task force screen, sound beams probe the water. Task force operations have been made more effective by development of the Integrated Command ASW Prediction System, called ICAPS. ICAPS is a computer software package that uses previously taken historical environmental data, as well as data taken on site. It also enables the task force to be independent of shore support for environmental and acoustical information. Men throughout the task force provide data for the system. They send this information to the analysis center. There, the bathymetric data are given to the computer as an input to the program. The computer processes it along with the stored historical data on temperature and salinity for these waters and calculates detection ranges for the various sonar systems carried in the task force. This system gives the task force a more effective real-time posture in defending against submarine attack. As the Navy continues its vital mission to protect the nation, Oceanography provides support to the fleet. Knowledge of the oceans and understanding how to use that knowledge to best advantage becomes increasingly important in a modern Navy, where the technology grows ever more complex. It is this understanding that is the key which opens the door to mastery of the ocean environment.